All right, we have some more new stuff. Okay, so the box and whisker was review. The new stuff that we're going to go over is normal distribution. Okay, so first thing is we have the normal curve. Okay, the normal curve, any data that you have falls underneath the normal curve. Okay, so we're going to set up our curve with some percentages. Okay, so everything we have, all the data falls underneath this curve no matter what data you're collecting. Okay, now the middle, I'm just going to give you this, we'll talk about it later too. Okay, the middle line here, let me make it a different color. This middle line here is going to be your mean. So the average of the data is going to fall in the middle. Okay, now we're going to figure out, I'm going to show you later how to find the lines to the right and find the lines to the left because they are going to be numbers as well. Okay, the middle two, so the closest two blocks, okay, right here. So this block and this block, these are both worth 34%, okay? Which equals 68, okay? So we'll talk about what all this means in a little bit, okay? But just know the first two blocks that are touching your mean are both worth 34%, okay? The next two are worth 13.5. Okay, both of them are both 13.5. Okay, now 13.5 on each side plus the 34 on each side gives you your 95%. Okay, so everything from the 13.5 to the other 13.5 and everything in between is worth 95% because all I did was add them up together. Okay. The next one is your 2.35, okay? Now, 2.35 is again on both sides, okay? When you add up the 2.35 to the 13.5 to the 34.5 on both sides, you're gonna get 99.7, okay? And then you'll have your, do the last one in gray, your last little pieces are 0.15. If you add 0.15 with all the other ones, you will get 100%. So everything underneath the curve is worth 100%. Okay, so your data set is worth 100% and you're putting it underneath this curve. And you're going to be analyzing it and asking questions about it. Okay? We'll talk about what a little bit more into detail next. Little yellow lines that I drew right here, okay? The ones right here, the ones right here, ones right here, 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 here. Those are all, we're going to call them standard deviations. They're represented by sigma, okay? Now, we're going to do something with those sigmas, or standard deviations, with our data, okay? So what I said before on the slide, so one standard deviation away from the mean is 68%. That's how I got this, okay? Two standard deviations away from the mean, okay, is 95%. Three standard deviations away from the mean is 99.7, and then 4 standard deviations away from the mean is 100. Okay, so that's what the next slide was. Here, okay, you know your little sliver is 0.15. Next space over is 2.35. Let's make sure I'm correct. Yes, 34, 34, and 13. Okay, so this is kind of like what I just talked about. Okay, everything, so in probability, your highest probability is 1. Okay, 1 as a percent is 100, okay? So all the probability is equal to 1. So your probability goes from 0 to 1. So all the decimals that do not have a 1 point something or 2 point something. So let's, for example, 0.5 or 0.35 or 0.2. These are all probabilities. Your probability cannot go over 1. Okay, and if I were to put these probabilities into a percent, these would be multiplied by 100, and it'll give you these percentages. These all fall underneath 100. Okay, so these 3 bullet points are like what I talked about before. Okay, 68% of the data lies within 1 standard deviation. Okay, 95% of the data lies within 2 standard deviations. Okay, and then 99.7 lies within 3. So talking about. Okay, 2, back, 5. All right. Okay, so what I'm asking you for is to give me the percent of the shaded part that's underneath the curve, okay? So underneath the curve, I'll write it in a different color so we can see it a little bit better, okay? So underneath the curve, I'm looking for this and this shaded part, okay? So don't worry about these numbers underneath, okay? We'll talk about that in a second. Okay, I want to know what probability is shown, okay? So I know that this little sliver here, if you go back, okay? So this is 0.15, this point is 0.15, okay? So you're just matching it to the other one. So 2.35, 2.35, okay? So what you're going to do is you're going to add them up together. So 0.15 plus 0.15 plus 2.35 plus 2.35 is 5, okay? So 5% of my data is shaded below, or shaded above right here, okay? All right, the next one. I'm going to shade it a little bit for you so you can see it a little bit better. I'm shading this part, and this part, okay? So going back to the table, or going back to the other standard curve, you know, this piece is 34%, this piece is 34%, and this one is 13.5%. Okay, so we're going to add those up. So 34 plus 34 plus 13.5 is 81.5. So 81.5 of my data is shaded below. Okay. Now, what this stuff means here, okay, all the stuff that doesn't just have an X is talking about the standard deviations, okay? So I'm going to make a curve here and I'm going to kind of explain it to you just a little bit better. So we have a normal curve, okay? Our mean falls in the middle. Now, when I said 1 standard deviation away, you're going to take your mean and you're going to add 1 standard deviation. Now, the standard deviation will be a specific number, okay? When I talk about finding the second line, you're going to take your mean and you're going to add 2 standard deviations, okay? When I look at the third line, I'm going to take my mean and add 3 standard deviations, okay? Same thing here, same thing on the other side, but subtracting. You're going to take your mean and you're going to subtract 1 standard deviation, take your mean, subtract 2, take your mean, subtract 3. Okay? So here, when I'm asking, now I could also label 34, 34, 13.5, 13.5, 2.35, 0.15, 2.35, 0.15, okay? So what I could do is I'm gonna do number 1 in blue, okay? So I'm going to assume, all right, for number 1, let me get my color straight. So X bar minus sigma, so mean minus sigma right here is this line right here. I need X values that are greater than or equal to that line. So greater than or equal to is going to be everything shaded to the right. So I'm going to add up all those percentages. Now, a quick, easy way to figure that out, your mean, guys, to the right is worth 50%. The mean to the left is worth 50%. So if half of your graph is shaded, just count it as 50. That's the same thing as adding 34, adding 13.5, adding 2.35, adding 0.15. So instead of doing all the work and adding up all those numbers together, you could just say, okay, well, half of it is already highlighted, which was from the mean to the right. So you could say 50 plus 34. So 50 plus 34 is 84. So therefore, 84% of your data is your answer for number 1. Okay? Let's do number 2. Number 2. You are trying to find X values that are less than or equal to the mean plus 3 standard deviation. So I'm going to find the mean plus 3 standard deviation, which is here. And I need X values that are less than or equal to. So less than or equal to is everything to the left. Or, let me shade it. It's going to be hard because I wrote my things in there. So everything shaded to the left. Okay? Now, you could do 50 plus 34 plus 13.5 plus 2.35. Or you could do 100 minus 0.15, because that's the one you did not shade, because you shaded everything to the left. Okay, so it's kind of like the linear programming where we were shading lines. You're finding your line, and then you're figuring out which way it's shaded, and then you're adding up those percentages. Okay, there's just different ways to add and subtract to find these. Okay, so if you wanted to, you could take 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15, or you could do 100 minus the stuff that you did not shade, or you could do 50 plus this one plus this one plus this one. There's different ways to figure it out. Okay, so if you were to take 100 and subtract 0.15, you will get 99.85. Okay, so 99.85% is your answer for this number 2. Okay, number 3. Okay, it says I need X values that are less than or equal to mean minus 3 standard deviations. So mean minus 3 standard deviations is here. I need X values that are less than that, which is everything to the left. Okay, you only have one number there, which is 0.15. So your answer is 0.15%. Okay. Okay. Now, this one, it's the same thing as last time. Okay, you have your normal curve. Here's your mean. Here is your mean plus 1 standard deviation, mean plus 2 standard deviation, mean plus 3 standard deviation, and then we just left off the 4, but it's there, okay? Same thing here, mean minus 1 standard deviation, mean minus 2, mean minus 3, okay? Which is these lines right here. Okay, I am looking for X values that are between the mean and the mean plus 2 standard deviations. So the X is your score that you're looking for, which does not have a bar over top, okay? So the number that you're looking for is between the mean and this number, okay? So I have the mean is one boundary, and mean plus 2 standard deviations is the other boundary. And I'm looking for a score in between, or a probability in between. So I'm going to shade in between, okay? Now I'm going to add up those percentages. Remember, this one's 34, this one's 13.5, okay? So when we add those two together, 34 plus 13.5 is 47.5, okay? So your answer here is 47.5%. Okay. A normal distribution with a mean of 25 and a standard deviation of 5. Now, I am always going to give you the mean and the standard deviation. So now instead of us having that weird notation with all the symbols, we are actually going to be labeling our normal curve with numbers, okay? So even though this middle line is x bar, you're not just going to put x bar there all the time, okay? X bar, remember, I told you is the same thing as the mean, okay? So instead of putting x bar there, when I give you numbers, you're going to put the actual number there, okay? So this line is now represented by the number 25. Now, standard deviation of 5. So to set up my normal curve, I'm going to take 25, I'm going to add 5 to get my next line. 25 plus 5 is 30. I'm going to add 5 more to get 35, add 5 more to get 40. Okay, so that's why I was adding a standard deviation every single time to the right, and then I add or subtract a standard deviation every time from the left. So take your mean, subtract one standard deviation, so 25 minus 5 is 20, minus 5 again is 15, minus 5 again is 10. So now your normal distribution curve is set up to reflect your problem. Okay, so now I need to find probabilities to answer these 6 questions to the left, okay? So my first one, number 6, I'm gonna do in red. Okay, I need to find the probability between 25 and 30. Well, that one's easy, okay? That's 34%. Going back to your normal curve that we went over at the beginning, okay? My next one I'm gonna do in blue, oops. I need to find the probability, okay? Or actually, let's go back to number 6, okay? In my problem, I'm asking for the probability. So I don't want this percent anymore. I'm gonna change this percent to a probability, okay? When you're doing a probability, you're going to divide it by 100. So even though your percentage is correct, I'm asking you for probability. So if I ask you for percentage, leave it. If I ask you for probability, divide by 100. So even though your answer is 34%, I'm gonna change this to 0.34, and that is my answer. So move the decimal to the left 2 places or divide by 100. Okay? So same thing for number 7. Now I'm going to go between 15 and 25. So 15 is here, 25 is here. So in between, I'm adding my 34 and my 13.5. So 34 plus 13.5 is 47.5. So 47.5% of my data lies between those 2 that I shaded in blue, but the probability is 0.475, and that is my answer. Okay, the next one is going to be in green. Now you're going to say, you're going to find the probability between 20 and 35. Okay, so you're going to add the 2 34s in the middle, and then you're going to add 13.5. So you have 3 sections highlighted. Okay, so you have 71.5%, but that as a probability is 0.715. Okay. All right, the next one is going to be yellow. All right, so at least 20. So remember, at least means 20 or more than. So 20, and then to the right. Now, a couple ways to solve this, okay? You have 20, and to the right, shaded. You could take 50%, which is half of the curve, and add 34, okay? Or you could add up 34 plus 34 plus 13.5 plus 2.35 plus 0.15. But since half of your curve is already covered or colored from this number 9 problem, you can take 50, add your 34. So 34 plus 50 is 84. So 84% of your curve is highlighted, but as a probability, it's 0.84. Okay. The next one I'm going to do, let's see, I'm going to do in purple. All right, so at least 40. So at least 40 means 40 or more. So here I have 40, but I need more than that. So I'm going to go to the right. Now, that is 0.15%. That as a probability is 0.0015. So it's really, really, really tiny. And I only really shaded something really small, so that should tell you that your answer matches. Okay? All right, and then I'm going to do my other one in purple as well. Okay. So at most 15, so that means 15 or less. So at most 15, so I'm going to shade 15, and I'm going to do less than. Okay. So I know that the last two are 0.15 and 2.35. Okay, so there's two sections there shaded, so 2.5. So 2.5% is the same thing as 0.025 probability. And there's your answers.